The lesson I want to talk about is factoring a trinomial. There are several points of information from previous lessons that we had earlier in the year that I want to recall for you. So when we multiply two binomials, there were two methods we talked about. One was box and one was FOIL. So let's go over that very briefly here. Remember, with box, you set up the box arrangement and you multiply to fill the boxes. And in FOIL, we looked at firsts, outers, inners, and lasts. But in either case, we would get the same answer. Remember, in the box method, we would add outers and inners, or these two boxes, the same as the girls who use the FOIL method. Now, one other concept I want to talk about before we actually factor is identifying factors. Here's a trinomial, x squared plus 6x plus 8. We need to look at the factors of 8, the last term. Factors of 8, 1 and 8, and 2 and 4. The other thing we need to look at now that we have these factors are which pair of factors have a relationship to 6, meaning which pair of these factors have a relationship to the middle term. So let's look at 1 and 8. 1 and 8, adding and subtracting would not give us 6. However, let's look at 2 and 4. If we added 2 and 4, we would have the middle term of 6. So 2 and 4 are the ones we would talk about for this problem. So again, what we're going to do is list factors and then look at the one with the relationship. So let's begin factoring. Here is a trinomial, x squared plus 7x plus 12. You need to list all the factors of 12. 12 has several pairs of factors. 1 and 12, 2 and 6, 3 and 4. Next point is, look at 1 and 12. Is there a relationship to 7? 2 and 6, do you see a relationship to 7? And then 3 and 4. Now to factor, we're going to make two sets of parentheses. And we're going to put an x in each first spot of the parentheses. That's for the x squared. Then you go over to your factors. You can see that 3 and 4 add to be 7. So we'll put a plus 3 and a plus 4. That completes the factoring, and this would be the factored answer. X plus 3 times the quantity x plus 4 is the factored answer for this trinomial. Now to check. Factoring is the reverse of multiplying two binomials. So what we're going to do is take our answer, x plus 3 times x plus 4, take your answer, and then use your box or FOIL method. When you do that, you will get x squared plus 7x plus 12, which is the original problem. So again, the check would be just FOIL or box, and you should get the original problem. Let's try another one. Here's our trinomial to factor. Factors of 15, 1 and 15. Now again, we're looking for what I call a relationship. Does 1 and 15 have a relationship, meaning can they be added or subtracted to make a 2, or 3 and 5? Well, 3 and 5 would be your choice, because 5 minus 3 is 2. So what we're going to do is get our first terms of x. Now we need to look at our 3 and 5. We have a negative 15. How can we get a negative 15? Well, negative 3 times positive 5, or positive 3 times negative 5. These are your choices to get a negative 15. Which of these added together will give you a negative 2? It's this one. This one would do it. If you add 3 plus negative 5, that's the relationship to get a negative 2. Those are the ones that would then fill in your parentheses. So, beginning with x to give you x squared, keep those in there, and then just fill in a positive 3 and a negative 5. Order doesn't matter here. So this answer could have been written x plus 3, x minus 5. Same answer. Because multiplication is commutative. Again, to check, take your answer of x minus 5 times x plus 3, use your box or FOIL method, and when you do that, work it through, first, outers, inners, last, and you can see that with that method you get x squared minus 2x minus 15, which is again your original problem. Let's try another one. X squared plus x minus 12. Factors of 12. 1 and 12, 2 and 6, 3 and 4. Again, we're looking for a relationship to the middle term. Keep in mind in this middle term, there's an invisible coefficient of 1 there. 12 and 1, 2 and 6, 3 and 4 have the relationship. Because we're going to look at these. We have a negative 12. Your choices are negative 3 times a positive 4 or a positive 3 times a negative 4. Which of these two pairs will add to a positive 1? Does negative 3 plus 4 add to a positive 1 or negative 3 plus negative 4? It would be this one. This is the one that'll go in your parentheses. So again, begin with the x as the first, and then fill in a minus 3 and a plus 4. Check. We're going to box or FOIL. Let's do the FOIL. X is x squared. Outers plus 4x. Inners minus 3x. Negative 3 times a positive 4 is a minus 12 for your last. And then remember, adding outers and inners, you're going to get x squared plus x minus 12. And again, that is the same answer as that. Checking is really important in this process because it's very easy to confuse the signs. So a check is really a simple process, and it doesn't take much work, and that assures you of a good answer. I'd like to try one more with you. X squared minus 5x plus 6. Factors of 6. Always list them all. In this case, you have two pairs. 1 and 6, 2 and 3. Now what makes these two pairs a little bit more interesting is we're looking at that relationship. Well, let's look at 1 and 6. Well, 6 minus 1 is 5. So we could use that one. But 2 and 3, they also have a relationship if we add these two. So now we have to look at something else. It's a positive 6. Well, it could be positive 1 times a positive 6, but it could also be a negative 1 and a negative 6 as the pair. Let's look at this pair, 2 and 3. 2 times 3 is 6, but also negative 2 times negative 3 is a positive 6. Now we can look at this. Does adding 6 and 1 make a 5? Adding 2 and 3 make a 5? But it's got to be a negative 5. Which of these pairs add to a negative 5? This is your pair to use. Negative 2 plus negative 3 is a negative 5. So again, fill in your x for first spots, and then I'll fill these in with a minus 2 and the minus 3. Again, if you check with the FOIL or the box, you'll get that answer. I'd like you to try these two problems. Work through those. Again, use your factors, look for a relationship, and check with FOIL.